Okay, let's do a lab about spanning tree, rapid spanning tree, and multiple spanning tree. Here is the diagram and the activities that will be included in this lab. So let's see. Use a rapid spanning tree. So D1 becomes the root for VLAN 1. Let's see who is the current root. So spanning tree. So spanning tree. It says gigabit 00. It should be number 2. So spanning tree. This is the root bridge, but we want, according to the lab, D1 must become the root for VLAN 1. So let's configure that. Spanning tree, VLAN 1, root primary. So this is now the root bridge. Notice that when you issue this command, show spanning tree, the priority is here, and the extended system ID is 1 because the VLAN is number 1. And if you add this number plus this number, you end up having this priority. So remember that in order for this to happen, you have to include the command that is the spanning tree extended system ID. This command comes by default, and this is the information about your bridge, and this is the information about the root. In this case, it is the same. It is the same information because it is the same switch. And when you issue this command, you can see that the protocol that is running. You can change this protocol by issuing the command spanning tree mode and choosing your protocol. But we're going to let it as is by now. And let's see what is the next. Use rapid spanning tree, so D2 becomes the root for VLAN 2. Okay, so now we have to create a VLAN because we only have VLAN 1. We only have VLAN 1. So VLAN 2, VLAN 2, VLAN 2. I am not using VTP, so I have to create the VLANs manually. So let's see who is the root for it's probably D2. Okay, it is this is the root bridge now because probably it has the lowest MAC address, but let's do this. It is recommended that you set this command so you are certain that this bridge will be always the root bridge. Spanning tree VLAN 2 root primary, just to make sure. Okay, this one is the root bridge for VLAN 1. Okay, what's next? Use rapid spanning tree to, so D3 becomes the root for VLAN 3. Okay, so we have to create VLAN 3. Oh, it's too bad I am not using VTP, but it is better this way. Oops. Oops. Okay. I have VLAN 3. in all switches. Now let's make D3 the root for VLAN 3. This is not a root now, but let's make it spanning tree, VLAN 3, roots, primary. So spanning tree, VLAN 3. This bridge is the root. Okay, what's next? Use long mode for interfaces cost. As you see, we are currently using the short mode because the gigabit interfaces are getting the cost of 4. So in long mode, gigabit interfaces should get the cost of 20,000. So let's issue this command, spanning tree, path cost, method, long. Okay. If I issue the command show spanning tree, now I can see that the interfaces have the cost of 20,000. So I have to repeat that command in all of the switches. Spanning tree, path cost, methods, long. Okay. Spanning tree, path cost, method, long. Okay. Spanning tree, path cost, method, long. Okay. Great. What's next? For VLAN 3 at switch A, if gigabit 02 is discarding, make gigabit 01 discarding. Let's see if that is happening. This is probably not happening, I don't know. Okay. Gigabit 02 is not blocking. I will make the opposite just to make a point. In this case, gigabit 02 is 01 is discarding. I will make 02 the one that is discarding. How I am going to achieve that? I'm going to modify gigabit 02 cost. Spanning tree, VLAN 3 cost. I'm going to make it bigger because lower is preferred. 25,000. Okay. If I now gigabit 01 must be forwarding and gigabit 02 must be blocking. Okay. So as you can see, I enter another value. Okay. Okay. Now gigabit 02 is blocking. Okay. Next, capture traffic and tell how many BPDUs get sent every 2 seconds. Let's capture traffic here. Maybe here. Capture. Okay. Let's see how many BPDUs. 1, 2, 3, 4 BPDUs. This is due that this is the standard BPDU. Per VLAN spanning tree will create a standard BPDU that has this app 42 hexadecimal and SURSAP 42 hexadecimal. The others are 1 BPDU per VLAN. This is for VLAN 3. This is for VLAN 2 and for VLAN 1. So I have 3 VLANs So per VLAN spanning tree is sending 3 BPDUs, 1 per VLAN, plus the standard BPDU. So I have 4 BPDUs every 2 seconds. Create an MST region using D1, D2, and D3. So I'm going to set an MST region with these 3 switches. Okay, in order to do that, I'm going to enter MST mode, spanning tree mode, MST, spanning tree MST configuration, name, home, okay, T2, T, spanning tree mode, MST, spanning tree MST configuration, name, home, and spanning tree mode MST, spanning tree MST configuration, name, home. So now we can issue this command, show spanning tree MST configuration. So we have the default instance that is related to all the VLANs. Show spanning tree tells me that I am running multiple spanning tree and using the region 0. Show spanning tree MST. Okay, will give me more information. Okay, great. Now I have a region between these 3 switches. Create a new instance for VLAN 2 and 3. So, okay. Spanning tree MST configuration, instance 1, VLAN 2 and 3. That's done. Conf spanning tree MST configuration, instance 1, VLAN 2, and I have problems with my keyboard. Okay, 2 and 3. Okay. Conf spanning tree MST configuration, instance 1, VLAN 2 and 3. Show spanning tree. Now I have region 0 and region 1. Great. Show spanning tree, region 0 and region 1. Show spanning tree, MST configuration, and I can see region instance 1 with VLANs 2 and 3. Okay, what's next? Create a new instance. Okay, verify port modes at the border. The border is between this switch that is D1 and A, and the other border is between switch D2 and A. So let's see. At D2, so you can see this. The port type is bound PBST, bound PBST. So spanning tree, bound PBST, bound PBST. Okay, and let's see at A how the ports are being. Remember that A is running per VLAN spanning tree plus, whereas the other switches are running an MST region. So I have interconnectivity between an MST region and a PBST plus. So show spanning tree. So on the PBST plus side, you will see this peer spanning tree protocol, and on the multiple spanning tree side, you will see bound PBST. Okay. capture traffic and tell how many VPDOs get sent every 2 seconds at the border. Okay, that is the same capture we are having here. As you see, the MST region is simulating a PBST plus switch, and it is sending as many VPDUs as a regular PBST plus switch would. So no changes here because from the perspective of switch A, the region is a big per VLAN spanning tree plus switch. So no changes here. Stop capture. Final point, capture traffic and tell how many VPDOs get sent within the MST region. So I'm going to capture traffic here because that is within the MST region. And let's see the VPDUs. How many VPDUs get sent? Only one VPDU, even though we have 2 instances, the default instance and the instance we just created. We only are sending one VPDU every 2 seconds. It's multiple spanning tree VPDU that includes the CIST, which is the information that corresponds to the region 0, and information that corresponds to the region 1. So this is information regarding region 1. And if I created more regions, I will still be sending one VPDU every 2 seconds. Opposite to what happens in per VLAN spanning tree, where you will be sending more VPDUs as you create more VLANs. Okay, hope that is help you for your study, and goodbye.